All right, we are starting to 4 properties from algebra. We're going over some algebra properties that you guys have seen last year, hopefully in middle school. Properties that we already know, so hopefully this should be a refresher, but we're also adding those properties into some geometry. So, all right, properties of equality. Like I said, you guys have seen these before. You guys are probably gonna have to fill in the blank. So addition property means if AB equals A equals B and C equals D, then A plus C equals B plus D. Meaning if I were to plug these in, anytime they're giving you something that has all these letters, just plug in a number so it's easier for you to understand. So let's just go ahead and I'm going to give you an example. If 4 equals 4, and 1 equals 1, then 4 plus 1 is going to equal 4 plus 1, okay? So that's just an example. They're just using the letters to show you that it can represent any number, okay? All right, so super important that you know this. And then subtraction property. If A equals B, and C equals D, then A minus C is going to equal B minus D. So I'm going to go ahead and just erase this right here. Okay, I'm going to use the same numbers. So I'm just writing it. I have A, which is 4, B, which is 4, C, which is 1, and D, which is 1. It's going to be 4 minus 1 is equal to 4 minus 1. So just showing you that they are equal to each other. All right, multiplication property. If A equals B, then, let me erase this. If A equals B, then 4 times, let me not use a highlighter. 4 times, give me a number, any number.
5.
All right, we'll keep them small. 5 equals 4 times 5, because I'm using 5 to represent my C, where C cannot equal 0. Okay, so it's still equal to each other. All right, looking at the next one. Division property, if A equals B, then A divided by C equals B divided by C. So I'm going to go ahead and use this one again. 4 divided by what? What number are we going to use? We'll do 8. Okay, 4 divided by 8 is going to equal 4 divided by 8. So when we're using property of equality, why is it using of equality? It's because you are moving, you are doing the same thing on both sides of the equal sign. Okay, that is my property of equality. All right, some more property of equality. We have substitution, meaning if I have x equals 4 and I have 2 plus x equals 8, I'm substituting my 4 for my x. So just writing that down because it sounds a little weird. If I had x equals 4 and I have 4 plus x equals 8, all I'm doing is taking this and plugging it in for my x, okay? That's substitution. If you heard of the word plugging in, it's the same thing, okay? Substitution, plugging in, letting something be equal to something else because they're giving it to you. That is substitution. Then we have reflexive property. Please don't get reflexive mixed up with symmetric. Reflexive is the same thing on both sides. It's the exact same thing. While symmetric is a reflection. So when you guys like look in the mirror, or if you mirror an image on a camera, normally the background is flipped. Okay, like the words are flipped backwards. So that's what symmetric is. So looking at my symmetric, have we heard of a line of symmetry?
Yes.
We've heard that before. So here is my line of symmetry. It's going to be the exact same. So looking at it, I'm going to have 2 letters and then my B, 2 letters and then my B equals A. And same thing on this side. So that is what it means to be reflection.
I kind of like math when I don't have numbers.
And then this one I'm switching. Yeah. The order. All right, next one is for this one, switching order and line of symmetry. All right, so let's look at transitive. Transitive, it says if A equals B and B equals C, then A equals C. What does this look like or remind us of? We recently learned. If A equals B and B equals C, then A equals C. What is this like? We just went over this. Laws of logic.
The pattern.
Syllogism.
Good. This is like the law of syllogism. Okay, so this is like law of syllogism. You were close. For this one, I'm trying to blend them together. Okay, I'm doing some sort of blending. And then we should know what distribution is. Distribution, distributive. Just distributing something. You don't have to worry about sum and difference. Just know that it's distribution. For these, you guys have used these in algebra. Now we're going to start using them in geometry. So reflexive property, you've used it for, it's true for numbers and variables. Now, since we're using geometry, it's also true for segments, which we should know what they are, and angles. Okay, so now we're using them for segments and angles. Symmetric. So symmetric is when it's reflected. Okay, it's a reflection, not reflexive, because that's different. We just did reflexive. Symmetric means it's flipped. So I have angle A. I'm going to go ahead and write my angle sign so we know we have to write it. Is equal to angle B. And angle B is equal to angle A, okay? So we can see that it's switched, okay? All right, and the last one is transitive. We said transitive is like what law? Good, this is like the law of syllogism. And looking at this example for angles, angle A is equal to angle B, and angle B, that looks more like an L, let me fix it. Angle B is equal to angle C, therefore angle A is equal to angle C. All right, looking at example 1, it says justify each statement with a property from algebra or a property of congruency. So we just covered the properties that we're going to use for today. And now we're just stating the properties. So looking at number 1, if AB equals CD, then CD equals AB. What property is that going to be?
AB plus CD and CD. Symmetric.
Good. It's symmetric. Okay, it's flipped. Think of my line of symmetry. So this is my symmetric property of equality. Oops, there are 2 M's. Yes, please. All right, looking at number 2, it says 3 times xy equals 3x plus 3. What property did I just use? Good, I'm distributing my 3 to everything inside my parentheses. And this is distributive property. All right, looking at number 3, it says if AB plus B, if 2A, plus B is 24, then B equals 4A, then 2A plus 4A equals 24. So looking at this one, I'm going to just highlight and show you what this one's talking about. I have B equals 4A. They're giving me my B, and I'm plugging in my 4A. What property is this one?
Addition.
Not addition. What? Good. I'm substituting what for what? I'm substituting, yes, I'm substituting my B for 4A, so this is substitution. Think about it as if your teacher's out, so my B is out, they're putting in 4A, and they're substituting it. It's like a substitute teacher. It's taking the place. All right, so looking at number 4, if x over 3 equals 12, then x equals 36. They're not substituting anything. There's no showing us some sort of plug-in. I'm solving for x. So think of a one-step equation. How am I getting there? What am I doing? What do I have to do?
You're multiplying.
I'm multiplying both sides by?
3.
Good. Multiplying both sides by 3. So for this one, my property is going to be? Multiplication. Multiplication property of equality, because I did it to both sides of my equal sign. I'm just going to shorten it, because you guys could definitely shorten it to the equal sign. We're going to get to proofs next. Yes. Looking at example number 2, it says justify each step. Now we're going to kind of get into proofs. So when you're dealing with proofs, you have this T-chart. So just go ahead and draw a little T-chart. And you have 2 sides. You have your sides with your statements. And then you have a side with your reasons. Okay, so proof means to prove something. So you are basically proving every single step. Okay, so if you're a person who's not good at showing your steps, or you don't like showing your steps on paper, you're going to have to start showing every single step on paper. So looking at this first one, 2 over 3x equals 9 minus 4x. They want me to justify this. Okay, justify each step. So they solved it for me. It's already solved. I just need to be able to give the reasons on what did I do. Okay, what did I use to solve this? So your first proof, your first reasoning is always going to be given. Why is it always given? Because it's given to me. How am I supposed to solve something if there's nothing there? Okay, so the first one is always going to be given. Anytime you see a proof with statements and reasons, and the first one, if there's a blank, given, it's always going to be given. So next, looking at it, how am I getting from 1 to 2? What did I do? I'm distributing. I'm not distributing yet. I need to figure out how am I getting from this first step to the second step. What am I doing, Bruce? No, you what was it?
I said you multiply.
Perfect. I am trying to get rid of that 3 because I don't want a fraction. So what am I doing? I am multiplying both sides by 3. So my property for my second one is going to be multiplication property. Multiplication property of equality. Okay. So looking at number 2, how am I getting from 2 to 3? How am I getting from 2 to 3? Okay, can somebody tell me what? Who said it? I'm not adding yet. I'm not there. How am I getting from 2? So how am I getting from here to here?
Distributive property.
Good, perfect. Distribution.
Oh, if I put like
No, distributive is correct. I'm using distribution, but the property is. If you put distribution or distributive, it's okay. Distribution property. So over here, I'm showing you for the next example, you'll see me do all this work and it'll be a little bit more steps because I'm literally showing all of it, okay? But yes, you have to write all of this on this side. If it's not given to you, yes. Okay, let's go ahead and go to the next one. How am I going from 3 to 4? How am I getting from 3 to 4? What am I adding?
the 12x to the 2x.
Perfect. I'm adding my 12x. Add 12x. So what property was that? What property did I just do? I did my addition property of equality. All right, so looking at the next one, going to 4 and 5. How am I solving from 4 to 5?
Division.
I'm using my division of what number?
14.
Good. I am dividing, so this is division property. All right, we're going to go ahead and do the next one. All right, for this one, it didn't give us anything. So now we have to solve, and we have to show our steps. So go ahead and draw your T-chart. Your T-chart. Your statements and your reasons. So we're going to go ahead and solve this together and justify our answers. So the first one is always what? Given 3x plus 2 equals 23 minus 4x. So my reason for this one, because I have to give my reasons, is going to be given. Okay, this one's given to me. It's given to you. There's no way I could have just pulled something out of the air. Okay, so it's given. All right. Please pay attention because it's a lot of steps that I'm going to show you. It's a total of, I want to say 6 steps, 6 to 7 steps. So please make sure you understand this. Yes.
So each one has a different number of steps?
Yes. Yes, they're not always going to have the same amount. For this one, everybody could kind of have something different because it depends on where you're going to start first. So there are a couple ways you can do this one, but personal preference, however you guys like to move things over, or if you would rather a negative number or a positive number. So would anybody like to tell me what to do first? What am I moving first? 4 or 2, which one are we doing?
Could it be 2?
So we could move the 2 or we could move the 4. It really doesn't matter. So I'll move the 4. We'll do the 4. And how am I moving my 4?
Addition.
Good. I'm adding my 4 to both sides. So keep in mind, I'm going to show you a little differently. So for this one, it's going to be step 2. And we said we're adding 4x. So I'm going to just rewrite everything. I'm going to write 3x plus 2. And then I'm adding a 4x equals 23 minus 4x. And again, I'm adding a 4x. So I'm showing you my movement. I'm showing you what I'm doing. So for my reasoning, it's going to be, oops, this should be a 2. And what's my reasoning? What did I just do?
Addition property or equality.
Good. This is going to be addition property of equality, and I'm just going to write in blue why it's addition property, because I'm adding 4x to both sides.
So we add the reason blue.
Do we have to add the reason?
You don't have to add the blue part, but you
You
have
say,
to
yeah.
add the reasons. Okay, you have, I'm only adding the blue part because you have to know what you're doing. Okay?
What does given mean? Like.
Given means it's given. Like,
it's
I,
there for you. It's there for you.
I can't just get 3x plus 2 out of nowhere. Like, it's what's given to me. That's what I'm trying to figure out.
Okay.
So that's why the first one is always going to be given.
And for add, we don't like need to keep solving the problem.
No, I have to keep going.
Oh,
I'm not
okay,
done.
okay.
Yeah, I have to keep going. All right, so for 3.
It would be division, no?
Okay, hold on. I'm just going to go ahead and now I'm going to add them.
Oh,
So I'm going to get 7x plus 2 equals 23 minus 4x. And for step 3, it's just I simplified. Yes. So you could see the movement.
So did we cancel out the 4?
So I just canceled out the 4 because I simplified. So for simplifying, I combine like terms. Perfect. Combine like terms. All right, so for the next one, number 4, what should I do next?
Try 2.
Oops, oh my gosh, you're right. I need to cancel this out. I need to get rid of this.
Wait, what?
I don't know why I added my 4x. I'm getting rid of it. Because they canceled out.
So,
Yeah, we were like confused for a second.
No, you're right. I canceled these out.
Okay.
All right, yes, so what should I do next?
add 2.
Good, we're going to go ahead. Am I adding 2?
Oh, my bad.
I'm going to go ahead and subtract my 2. So I'm going to do 7x plus 2, and I'm showing you my movement. I am subtracting 2 to both sides of my equal sign. These are going to cancel out. And for my step 4, what did I just do? What property?
Subtraction.
Good, I subtracted to both sides. So subtraction property of equality, and I subtracted 2.
Do you have to put, like, of equality, or can you just put subtraction property?
No, she said you can just put that. Like, she's not-
Subtraction property of equality.
You have to put the of equality?
Mm-hmm.
Oh, so we just gotta put subtraction property of equal, basically.
Just of equal is fine. Yes. You don't have to show what's in blue, but you do have to give me those reasons. Okay. All right. So number 5, I'm just going to go ahead and combine my like terms. 7x equals 21. So for 5, I'm going to write simplify. And I simplified by combining like terms. Combine like terms. And then 6, what should I get? We could kind of solve it.
You divide.
Yeah, I'm dividing, but I'm just going to go ahead and solve it. What should my answer be?
3.
X equals 3. And how did I get there?
Division.
Good. So my last one, 6, should be division property of equality, because I divided to both sides. So just showing you without writing simplify. That's my movement. And this is division. Or I'll write divide 7. Why doesn't this eraser work?
Wait, hold on, I messed up. Can you do that for me?
Divide, yeah, give me a second. Divide 7 to both sides. Okay, and that is our first proof. You guys just did your proof.
That's easy. Why are people saying it's so hard?
It's beginning is always easy. So
Oh, God.
it's, yes, 100% very tedious. You have to make sure you're showing your steps.
This is like the basic.
This is the basics, but if you understand this, when we apply geometry, you should be able to figure out how we're doing it, okay? So this is just make sure you're showing your steps, okay? So, does anyone have any questions on this?
Nope.
All right. Looking at example number 4, go ahead and do this one yourself. So, a couple things you could do for this. If you want to solve it first, you could solve everything first and then write your reasoning next, okay? So before we did solve, reason, solve, reason, solve, reason. But if you want to solve everything first, you can solve everything first and then do your reasons last. So it's totally up to you how you want to do it. Okay, go ahead and solve for R. All right, so first thing for this one, we're just going to go ahead and rewrite what they're giving us. So I have my P times R plus 1 equals N. How about let's just solve it first and then plug our reasons in. Okay, so looking at number 1, what should I do next? I'm going to go ahead, I should have wrote it a little smaller. We're going to go ahead and distribute. Okay, so actually let me do it on the bottom. I'm going to go ahead and distribute my P. So for my second step, I'm going to have, PR plus P equals N, and what should I do next?
Subtract. Oh,
Yes?
subtract 1.
Okay, so remember, P times 1 is P. Okay, it's 1P. So I'm not subtracting my 1, I'm subtracting P. Okay, so for this one, I'm going to go ahead and subtract P to both sides. Remember, we're trying to get R by itself. So my step 3, I'm going to have PR equals, yes, PR equals N minus P. Looking at the next one, what should I do? I'm trying to get R by itself. Not subtracting. Remember, when you have two letters next to each other.
Divide.
Good. So I'm multiplying P times R. I need to go ahead and now divide by P, because remember, I'm trying to get R by itself. And then I'm just going to have my answer. R equals N minus P over P. And let's go ahead and write our reasons. Reason number 1 is always given. Good. Reason number 2 is what?
Distribute.
I distributed.
Do we say distributive property or just distribute?
Distributive property is fine. All right, my step 3, subtraction property of equality. And then step 4.
Simplify.
Not simplify. So, okay, just to clarify, when you guys are looking at it, this is always the first one. Your step 2 is always asking, how am I getting from 1 to 2? What did I do? I distributed. How am I getting from 2 to 3? I subtracted. How am I getting from 3 to 4?
Divide.
I'm using the division property. Division property of equality. And that is it for 2.4. Do you have any questions? Yes, because I'm doing it to both sides of my equal sign. Do you have any questions on this?
No.
No? Okay. Bye, see you later.